I'm
This
providing the
conference will
trainings on
now be
Snowflake.
recorded.
Okay, and I'm a data architect. So I'm working for data ingestion tools like Python, DBT, Medallion, IACS Cloud, and also data visualization tools like Tableau, Python, Grafana. So these are all my areas. So I'm working on Snowflake along with AI. So that is Snowflake Cortex and Streamlit applications like open source data sources. So this is my experience, and let's start our Snowflake session. So first thing is, what is Snowflake and why we need as a Snowflake. The Snowflake is nothing but it is a cloud data warehouse, and it can store and it can analyze the data. So what can store it? So it can store the data and also analyzing the data. What is data analyzation? So the analyzation is nothing but, so whatever the data you are getting in the form of raw. Raw is nothing but it is a combination of special symbols or empty fields or data date format changes. So many. So you want to analyze all the data. So you have to cure the data after analyzations. So this process of curation we can call it as a transformations. So the transformations are nothing but changes in your data. So whatever the data you have been ingested into Snowflake, the Snowflake will store the data and then we analyze the data. So at the process of analyzation, we do some transformations on the data. Transformations are nothing but changes, based on the client requirement. So accordingly, we can change our data in Snowflake. Okay, so before we are going to discuss about a Snowflake, so we need to discuss about as a data warehouse. So what is data warehouse and what is database? So but Snowflake will act like a database and as well as data warehouse. So how it is possible with Snowflake? It is not like a on-premise application. So it is a online application, like it is a SaaS. Okay, it is a service of SaaS. So basically we have three types of services. One is platform as a service, and next is software as a service, and one more is infrastructure as a service. So now the Snowflake is a software as a service. So what is platform as a service? The platform as a services are nothing but a platform dependence. That means which the platform services needs a installation, needs a software. Okay, it needs a software to install on your data in your systems. Like for example, Java. Okay, in example .NET, example SQL Server. So if I want to access the SQL Server, how it is possible? So first we have to get the software, and if you had a software also, you have to install in your local system. That means this software needs a platform to install. Then only you can access the, or you can process your data. Right, for example, I have a SQL server, so I want to get this SQL server. Then how can I use this? Because it's been installed on my local system, then only I can access this SQL. So that means it is completely depends on my laptop or completely depends on my local system. Then only I can access with the authentication process. Then I can easily connect and I can do my proceedings. But it is not accessible by the other end, like globally I cannot access this, because which is installed on my local system, it is having some privileges to access. Okay, so this kind of services we can call it as a platform as a service. It is a platform dependence. So we cannot access globally, it can access only for the same system where you installed, and also it is having some software cost to buy. The companies has to take the premium for this any one of the softwares, so they will buy the softwares and then they need installation is required for the platform as a services. Clear? And then software as a services are nothing but, so software, the software which is already been created. Okay, it is already being created, we just want instantly you can access the softwares. That means it is already built and it is already there in server, so we just take a premium for this. For example, I have a Gmail, so if I want to access a Gmail, so how can I access a Gmail? So simply you can do the sign up process and then you can sign in your account, and wherever you create this account, yes, it will be open across the world. So what is the mean of this? The service is available globally. It is not platform dependent like a pass. Software as a service is a software, it is predefined. So we just use that software with the help of the SaaS services like Gmail. So the Gmail is the best example to understand. So it is only having internet connection. So you just go to the URL, you just use the sign up or sign in process, then you can enter. If you are created this Gmail account in India and you can access anywhere in the world. So that is the possibility is called as a platform independent. It is platform dependent, wherever you install there itself you can use, but it is not like that. Wherever you can go and you can open your software as service, any one of the tools like Gmail, and we have IACS cloud, Matillion, Tableau, Snowflake, AWS, so many things, so many applications are doing the same as software as a services. Okay, it is a service for the software as a service, and it is for the platform independent. It is globally available, so it is available for all with the authentication process. Okay, without authentication you cannot access, and you need an URL and username, password, or authentication users, then only you can access this software. But this, it is not like that. You need a authentication, and also which is need installation, which needs a software, everything is needed as a pass. And what is infrastructure as a service? Infrastructure is nothing but one area you have to become. For example, if you are building, or if you are doing your new job, like a, for example, if you are going to start your new business. Okay, it is a startup company. So for example, I am going to start up one company ABC. So if I want to start this business, then I have to take a, that is I have to build one infrastructure. That infrastructure includes what are the, so how many employees I need, so what is the infrastructure I have to build, like how many computers I want, so under this computer what are the softwares we need to install. So we have to buy all kind of information. So either that has to be platform as an in services, or either you can buy, take a premium as a software as a services. Simply I can call it as the combination of this PaaS and SaaS, and it is manually you can update. So but the software as services we cannot manually update, automatically the updation has to be done by software. So the platform as a services also needs a manual updations. So but IaaS is having the combination of these two as platform as a service. For example, this computer needs SQL, then you have to install your SQL software like into the your computer. For example, I need a Snowflake, so the Snowflake is a SaaS. Then if I want to access the Snowflake as in company as an infrastructure as a service, yes, you can take a premium of Snowflake and you can access anywhere in the company. So either you can use the platform as a services or software as a services. It is completely manually operated, and whatever the updations and upgradations, everything has to be handled by the user. Okay, it is handled by the user. So now this is the difference between the services. So PaaS, SaaS, and IaaS. Now the Snowflake is a SaaS service. So we have been used this SaaS service. It is globally available. It is platform independent. Okay. Now we are going to discuss about a warehouse. So what is data warehouse? So the warehouse is nothing but So the database, first thing is database. What is database? It can store the data. That's it. So for example, in SQL, so if you insert any values, right? If you are inserting values into the table, the values has to be inserted into databases. The database, okay. So the storage of your data. So the warehouse is nothing but it is not only the storage, it is having the three factors. Okay, so those are we can call it as a resources. So I can call it as a compute resources. Okay, what is the definition of a data warehouse? It is a cluster of it's a cluster of compute resources. So what is cluster of compute resources? Let's see the let's later we discuss about a cluster. First, what is compute resources? What are the compute resources are being used for the warehouse? So first thing is the CPU, that is called as a processing unit. Okay, the CPU, and then the second one is a storage. Okay, first is CPU, that is the processing unit. What is processing unit? It is processing your data. Okay, it is processing your data based on your RAM. So for example, I'm just comparing with your local system. For example, I have a computer, that computer having, okay, the computer having uh, i7 processor. Okay, this compatible with the 16 GB or 32 GB of RAM, right? The RAM is required to process this data. So this is a processor, and if I want to process this, the compatible RAM is required. In the same way, here is a processing unit as a warehouse. If I want to process, I need a RAM. So that RAM we can call it as a speed. So we can call it as a clusters here. The speed of execution. The speed of execution is depends on the cluster operations. So I can consider as a speed. So now the CPU, the processor is a CPU here, and the 16 GB RAM is nothing but it is speed of processing unit it is, and then storage is nothing but here the computer is having the processor and RAM with the hard disk to storage, right? So these three are mandatory for every computer, any computer. In the same way, if I want to process a warehouse, if I want to create any data, if I want to store any data, if I want to process any data, I need these compute resources. What is computing is nothing but compute is nothing but processing your data. Okay, if I want to process any data in Snowflake, I use this warehouse. Now the warehouse is going to process your data with the help of CPU and the speed and along with the storage. Once I pass any data into warehouse, the processor has to take care of this and along with the speed of execution, and once it is processed, it will be stored on storage area. Okay, so simply I can call it as the warehouse or data warehouse or virtual warehouse. Both everything is same. Warehouse, data warehouse or virtual warehouse. So why this virtual warehouse? We'll discuss later at a multi-cluster concept. Okay, and now it is a warehouse is nothing but simply we can call it as data warehouse or virtual warehouse, and it is having the cluster of compute resources. What are those resources? The resources, one is processor, and then it is a speed like a RAM, and one more is storage as a hard disk. So these three are important, and these three is having as a warehouses, but these three will not have as a DB, it is only having the storage. Okay, it is only having the storage. Now the warehouse will do these activities, and it is completely depends on these resources to process your data. Now clear about this, what is warehouse and DB, the difference. So now Snowflake is a cloud data warehouse. It can store and analyzing data, analyzing with the help of this processor and speed. Okay, the warehouse is playing an important role in a Snowflake because the Snowflake is a cloud data warehouse. Remember, and completely depends on the warehouse only. So if you want to process your data, what is the speed of your executions and what is the storage of your warehouse, everything is defined under this warehouse level. The warehouse containing all the specification of your speed, storage and processing. Okay, without warehouse you can't process data in Snowflake. Clear up to this? Any doubt up to this? Do you have any doubts up to this? Okay. If you don't have doubt, then I just move for the next. So now the data warehouse. So the Snowflake is a cloud data warehouse. So it is completely processing your data. Okay, compute resources are nothing but processing of your data. Okay. So how can I process and where it will store? So every application, any software application is having their own architecture. So now the Snowflake is having the unique architecture. So this architecture containing three layers. Okay, the Snowflake is completely blindly depends on this unique architecture. So without this architecture, there is no Snowflake. Okay, so what is that architecture and what is the layers of this architecture? The first layer is storage layer. The storage layer is nothing but whatever the data you have been loaded. That means, for example, I have a AWS cloud provider or Azure cloud provider. These are all cloud providers. The basically we have three cloud providers like AWS, Azure, and GCP. So let us consider the client is located the file at AWS. One file is available at AWS cloud. I want to load this file into Snowflake as a table. How can I do that? Using data loading. First, we need to integrate the two applications like Snowflake and AWS, and then I can load the data. So once I connection has made, so then it will be loaded into the Snowflake into the storage. So that storage we can call it as this one, the storage layer. So whatever you loaded from the AWS cloud provider to Snowflake, the data loading process that will be stored as a storage layer. This is one way. And what is another one? If you are writing any query, for example, I'm creating customer table, I'm inserting values into customer table. Okay, in Snowflake, I'm talking about. So I'm inserting values in Snowflake. So those values will be stored in a centralized storage. Okay, those values will be stored in a centralized storage. This is second way. And what is the third one? So if you have, okay, if you have different resources like this is the image you can find out. See, for example, if you have a data, either it is SAP or Oracle, Java, .NET, whatever it is, you have a sources. We have different resources. You want to move the data. You are maintaining some data as an existent servers. So you want to move this Oracle data into Snowflake. So how can I do this? First, you have to choose any one of the connectors. So for example, I'm going to take ETL process with the help of Informatica Cloud, any one of the cloud provider or any one of the ingestion processes using ETL or API. So for this reason, I am going to make a integrate between two different applications. Snowflake is different application and Oracle is a different application. I want to integrate these two data and then I can process the data and I load the data into Snowflake. So how it is possible? So with the help of ETL process, I'm extracting the data. Extracting, that is called as squeezing the data from the Oracle, taking the data from the Oracle. I'm having I'm having 100 tables. For example, I'm having 100 tables. So I want to move these 100 tables into Snowflake. So how it is possible? I'm getting extracting data with the help of Informatica. Okay, I'm extracting data from the Informatica. It is extracting the data from the Oracle and it is transformed. Then we can transform the data. Transformation is nothing but I can change the data whatever you extracted from Oracle. So what is extra transformations? For example, in Oracle, I have 100 tables. The 100 tables containing different columns. If you want to change any columns, if you want to remove some columns, I don't need whatever the columns it is having as an Oracle. I want to remove the whatever the columns you have been ingested. So you can remove the columns at the time of transformations from a tables. So Not only one, okay, not only one, you can do n number of transformations on your data once you extracted the data from Oracle to Informatica IICS cloud. Then you can do the transformation, then finally you can load the data into Snowflake. So the loading data into Snowflake, we can call it as a data ingestion process. I'm ingesting data from Oracle to Snowflake with the help of ETL. So now the data will be landed on Snowflake. Okay, the data whatever you have been moved from Oracle with the help of ETL, it has been moved into landing zone. Landing zone is nothing but it is a schema, it containing the group of tables information. Now all the 100 tables will be available under this landing zone. So the 100 tables information is available as a landing level because the data has to be landed as data ingestion process with the help of this ETL, right? So the data has to be loaded, like the data has to be ingested. So the data has to be stored at a centralized storage level. Okay, and these are the many ways. Okay, we have many ways as data loading, data ingestion, data insertion. So whatever the activity you have been, so those will be stored as centralized storage. Okay, the centralized storage. Now this is the first layer and we'll discuss in detail on the next class, but this is the architecture I'm going to be discuss. What is storage? It can store all type of data loading and all type of data insertions and all type of data ingestions. Okay, insertion is nothing but within Snowflake. Ingestions outside Snowflake, you want to be load the data from any one of the sources like Oracle, SAP, whatever the different applications. You want to move the data, then we have to ingest the data into Snowflake. Okay. So this is called storage layer. And what is the second one? It is called as a compute layer. So in this compute layer, we have the development activities. Like if you want to write a code as a SQL, yes, you can write a SQL code. If you want to write a Python using Snowpark, yes, we have a feature called as all Python libraries are available. Okay, to build your application to process your data, yes, it is possible in Snowflake. The development activities, everything under the compute layer. I told you before itself, the compute is nothing but processing. Okay, now using this development area, I am processing my data. Either you can use SQL commands or either you can use the Python. Yes, I can process my data using, that is called as processing layer, or you can also call it as a compute layer, and also you can call it as a virtual warehouse layer. The virtual warehouse is nothing but compute resources. So everything is possible for the processing data, right? And one more is called data loading. See, if I want to load the data, the process is needed for the integration process, right? We need a connection. So everything under this data loading level. So you can load the data from the local system, you can load the data from the AWS cloud providers. Okay, anywhere you can load the data from the different stages. We'll discuss what is stages and why it is required as a stages. Everything in detail we discuss. Now the data loading is nothing but if you want to load the data, you have to write some integration processes. So you have to follow some instructions to do the connection between two different applications while loading the data. Yes, it is possible at the time of compute layer. The compute layer is completely for the data loading and the development activity, and the normal users, okay, the unknown users, like they don't know about a SQL and anything. So the technology they doesn't know, the non-technical people will look at the data, they will not understand the data whether it is loaded or 1 lakh records or 2 lakh records. They want to get the filter out, like what is the maximum one, what is the minimum one. So with the help of this ad hoc analytics, we have some graphical representation in Snowflake to understand the data whatever you been loaded. So you can filter out the data with the help of the filter options using this ad hoc analytics. Once you loaded the data into Snowflake, okay, you process the data, you can load the data, and you can analyze, that is analyze the data with the help of ad hoc analytics. So all these possibilities available at processing layer, that is called as compute layer. This is the middle layer of an architecture. Okay, and once you process the data, then it will be stored in the storage area, that is called centralized storage layer. It is for processing, it is for loading and inserting and storage the data. You have to write a code like a insert into, and once you the execute that command, it will be stored in a storage layer as a database. And then what is the third one? This is called as a cloud service layer. Okay, the cloud service is nothing but it is having the all the security related info. That is, if you want to transact the data within the Snowflake or outside the Snowflake, by default the data has been, it has been as it is including as a security. Yes, every data has been so having the security, okay, the feature available at the time of data loading and unloading processes. Yes, it is by default Snowflake is providing the security. While you transact between any Snowflake account to another Snowflake account, yes, you can do the transactions with the help of security. So we have a data sharing concept. So we have some limitation to share the data between two different accounts. Yes, with the help of security, you can share the data in the form of metadata. So the metadata is nothing but read-only access. So the original data will not be processed. The metadata information will be passed by one Snowflake account to another Snowflake account because of data security reasons. Okay, if I pass the original data to other Snowflake account, they will have the rights on this to edit everything on the data. So the editing or customization on this original data, it is not accessible with the help of the security. So this kind of okay, this kind of activity, it belongs to the metadata has to be removed, and the metadata is nothing but read only access. Okay, it can pass only read only. That is, you can query the data, you cannot access the data. You can access the data, but you can edit the data. You cannot change the data whatever we have been shared. So that is called as security. With the help of metadata, you can transact your data from one Snowflake account to another Snowflake account, and that could be in the form of metadata. Metadata is nothing but the physical information read only format. We cannot edit the data whatever we have been shared from Snowflake account. Okay, and like that we can do the managed, so you can manage the data, you can optimize the data. Optimization is nothing but within less time you can process a number of, okay, and a huge number of data. So you can optimize with the help of, okay, processing. For example, if I have 100 queries, the 100 queries will be executed within 10 minutes. But if it is not done at 10 minutes, the 100 queries will not be executed parallelly within 10 minutes. Then what you have to do? So you can do the optimization process, like either you can increase the cluster or you can increase the size, depends on your requirements. So whether which is required to increase and decrease, okay, scale up and scale down. Okay, so we have some scaling processes. So using this optimization technique, you can reduce the time and you can reduce the cost also. Okay, and like that, the data optimization has to be worked for every user based on their analyzation process. So this is the importance of data architecture. So it is a Snowflake data architecture. So here the important features they mentioned here, that is called as instant and automatic scalable and elasticity. What is instant? If I do any sharing between two Snowflake account, so for example, I have customer table. I want to be shared this customer table to other Snowflake account. Yes, if you shared with the security within seconds, that is called instantly the data is available on other Snowflake account. Yes, instantly you can share it. Yes, instantly you can access the data from any Snowflake account. Okay, what is automatic scalability? The automatic scalability is a kind of one optimization technique. So automatic scalable is nothing but, so based on your input, based on your workloads, okay, based on your workloads, let us consider I have a 100 MB file. So I have an 100 MB file. So I want to process this 100 MB file. So that needs, okay, that needs a 2 GB RAM to process my data. No, it is having 1 GB data. Let us consider, I'm not talking about clusters. Now I'm just talking about the speed of execution. Now 100 MB data, 1 GB RAM is enough. Okay. And two, for example, I have 1 GB data, then 1 GB RAM is not enough. I need a 2 GB RAM to process my data. Okay. So if I have 100 GB data, then so the 2 GB data, 2 GB RAM is not enough to process my data that is executing. So 100 GB data if I process, I need a some 4 GB or 5 GB RAM need for the processing my data. So as manually I can consider based on my size of file. So it has to be allocated as 5 GB and 1 GB for 2 GB RAM and 100 MB for 1 GB. But in Snowflake, whatever the data you have, so we have a concept called as multi-clusters. Okay, we have a concept called as multi-clusters. We have designed the multi-clusters with the range. So we have minimum is 1 and maximum is 10 clusters. That is 1 GB RAM and 10 GB RAM maximum. So you can compare with it as a RAM, no problem. These are called clusters. The clusters are doing like speed of execution of your queries. So if I want to process with the help of query, the query having 100 GB data, okay, that query having 100 GB data. So for that, which is a suitable cluster, which is suitable RAM. So automatically the scaling process, we can call it as a scaling. Scaling is nothing but speed of execution. So now for 100 GB, I suggested as 5 GB as manual, right? So but Snowflake is automatically calculates this data. So after selecting, for example, insert into values of some values I'm inserting. This is containing 100 GB worth. So I'm inserting data as 100 GB. Then automatically the multi clusters has to be calculated. The relevant cluster will be activated. Okay, from 1 to 10, so it is a range I have defined from 1 to 10 which is suitable for this processing. For example, 5 GB is processing. 5 clusters are needed for this. So the 5 clusters are activated. 5 clusters will be activated to process this data. Once 100 GB data will be processed successfully into Snowflake, then the 5 clusters will be, okay, going to the default as 1. Okay, the 5 clusters will not be inactive. So it is only back to the default. Okay, back to the default, that is one cluster. So whenever the scaling, the speed is required, then only the cluster will be activate the relevant clusters to process our data. Once it is done, it is back to the default as one. So that is the beauty of multi-cluster concept. So that will be available as a, okay, as automatic scalable. And what is elasticity? Elasticity is nothing but if you have 1 GB data in, then the Snowflake is allocated 1 GB space at cloud. So if you have 10 GB data, then 10 GB data has to be allocated at storage in Snowflake. So if you have 100 GB, then it is also allowed you for the 100 GB. So whatever the data you have, either it is smaller or bigger one or bulk data you have, so based on your requirement, the Snowflake is allocated. That means it is elaborated or that is extended the space of cloud based on your inputs. So that is called as, that property we can call it as elasticity. So if you have 1000 GB, then 1000 GB data has to be maintained at cloud level. So it is allocated 1000 GB. Yes, it is possible. So that property we can call it as elasticity property. Right? Hope you understand everyone about this architecture and these features. Any doubts up to this, please? You want to ask anything about that is architecture and any data warehouse concepts? No doubts? Okay, then we'll just go for the roadmap of Snowflake. See, we have two types of worksheets in Snowflake. Once you sign up the Snowflake, it is a free trial version and it is containing 400 credits of worth, and the Snowflake currency is nothing but credits. So we'll discuss. Okay, but now I want to show the roadmap. What is the Snowflake? How it is looking like? This is the user interface we are getting. So as a user interface, this will be called as a snow site. Okay, this user interface we can call it as a snow site. So here we are going to work with the SQL worksheet and along with the Python. Both will discuss. The SQL worksheets will be looking like this. So now see, I am doing some data sharing concept. So I'm writing some code for the data sharing. This is called as a SQL worksheet. And what is Python? See, this is Python. Okay, this is the Python. So here all the libraries will be available to get like NumPy, Pandas, whatever you want. So if you want to get the packages, you just type and it will get as a Panda. See, look at this. If you select, automatically the libraries and packages will be added to your worksheet. See the latest version of 2.2.3. So if you need a older versions, then that is also available to process your data. It's up to wish. That is whatever you want. If you want to add and process your data as a Python, and this worksheet we can call it as a Snowpark. Okay, Snowflake with Python. Okay, Snowflake with Python. See here we have two types of worksheets, SQL and Python worksheet. Now this is a Python worksheet, and if you want to write any Python information, so it is a kind of oops concepts and all the try and catch blocks and whatever you want to be used as programming languages. The programming languages will be written inside the Snowflake, Snowpark worksheet. So the SQL commands will be executed on this level. So this is the code I have given as for the task creation. So now this task is being executed. See, this is the table. So I'm creating one table. So this is a simple like a SQL, and we have some concept called as task. Then if you want to create a task like this is the syntax of task. So this is all SQL, and whatever this area data sharing and whatever it is, this area we can call it as, okay, this one, this white color. So this is as a warehouse layer. In architecture we have a middle layer, right? If you want to load the data, you have to write a code and integrate. See, look at this. I'll just show you the data loading. So where is data loading? So this is the data loading one. If you want to load the data, you have to integrate first, and then you can do connection, and then create a file format, and then you can do the integration with the stage creations, and then copy into command. So everything on written as under compute layer. Okay, this is called computing layer or virtual warehouse layer, or this is a compute or virtual warehouse or processing layer. I am processing my data to load my content from AWS to Snowflake. That AWS is this one. The S3 is, the file is available as sample CSV. I want to load the data with the help of. So like this, you can compare your. See this one. The development is nothing but now I am doing the development with the help of SQL. So this is the SQL commands. Now this is the development area for me. So these two are development area like SQL and worksheet and Python worksheets. Okay. So now, so what I have been covered in these sessions. So I have been covered from the scratch. Okay, from the scratch. That is from beginning to ending. That is called as an advanced level. So now I can start with the sign up process, and then I can discuss about a cloud providers, credits information, addition information, and then we'll go for the data warehouse concepts. That is what is data warehouse, how to create a data warehouse, and what is virtual warehouse, what is cluster, what is multi clusters. So everything will detail will cover. Okay, and then Snowflake objects, database creation, schema, table creation, and then we'll discuss about those are not having the SQL syntaxes, not having the knowledge on SQL. Then I just give the brief about a SQL commands like this. So I can use the join operations. I just explain in detail. So like this creation of table, how to insert, how many ways to insert. Okay, we have different ways to insert the values. And join operations, the join operations are very much important in Snowflake development. Okay, how do we do this? That is join operations. What is left join, what is inner join, what is right join, everything will detail. So this is the code I have been. So I'll explain. Those are not having the knowledge on SQL. If you have, then we can skip this one. Okay. And then and I go with query history and cache. The query history is nothing but whatever the queries we executed, that information has to be available for referencing. What query you executed, select star from student details, whether it is succeeded or not. So when who is executed, this is the user, and by which warehouse, my warehouse. So like this you can find out your activities and you will get all the details of this information. See, you are inserting these values into this table. So everything in detail will be query history. What is query history and what is cache we have been used? What is the purpose of cache? We'll discuss as in this level. It is also very important for us. And once it is done, I can go for the type of objects or type of tables. We have internal and external tables. So what is external table and what are internal tables? What is internal table? Internal tables are again divided into three types. One is permanent, and the second one is, we have three types: permanent, transient, and temporary. So in detail we discuss as what is transient, what is temporary, and what is a permanent. Okay. And then once it is done, we go for the time travel concept. It is the one of the feature, one of the advanced feature in Snowflake. What is time travel? So how can we declare as a time travel and fail safe? These two are related to this one. And then once it is done, I can go with cloning. Cloning is one of the backup technique in Snowflake. We have two types of backup techniques in Snowflake. One is time travel and is cloning. So we'll cover all the real-time hands-on, okay, examples with it in detail as theoretical as well. And once it is done, I can go with the data loading. At the time of AWS, okay, at the time of AWS, I just I'm using the S3 services and identity access management services. Here I'm creating role. This role is going to access the S3. So what is S3 service and what is identity access management? With the help of these two, how can I load the data from this S3 to Snowflake at the time of data loading process? So we discuss as an AWS as a cloud provider to load the data from AWS to Snowflake using data loading. Okay. And once it is data loading, we do the unloading process as well. Unloading also important. Data loading and unloading. Unloading is nothing but reverse process from Snowflake to S3. Loading is nothing but S3 to Snowflake. So we can do all at a data loading level, loading and unloading. And once it is done, we can go for the automatic data ingestion process. It is also one type of data loading process, but it is automatically executed. It is manual loading and it is automatic loading. So I'll share the differences and what is the code we have to write as Snowpipe. Everything we have to create a notification channel to trigger whenever the file is uploaded at S3 level. Automatically the Snowflake will load with the help of Snowpipe data pipeline. So automatically the data will be loaded. So with the help of this auto ingest is equal to true parameter. Everything in detail in Snowpipe. Okay. So this is data loading and Snowpipe. And then later, once it is done, I just go for the materialized view and secure view. So what are the different views we are having? What is the difference between a normal views and materialized and secure views? With hands-on. Everything is hands-on as a real time. And then I'll go for the task and streams. Okay, task and streams. This is a real-time approach. The task streams are very much required. 80, not 80%, 90% is required as a task streams while data loading. So what is task and what is stream? I'm using this both and I'm loading the data into Snowflake as a real time. So this is the one. And then resource monitor, it belongs to the admin activity, and we'll do this. and then clustering, that is multi-clustering time, we can do the clustering one. And then the data sharing concept, data sharing. So how can I share the data between two accounts? So that will be covered as data sharing. And then data masking, how you can hide your sensitive data to others. Unauthorized people will not show the data as a column level. So how can I do this column level security? How can I provide a column level security at data masking? At the time of data masking, I am okay explaining the what is RBAC. So role based access control. So at the time of data masking, I use the, I can explain the user defined functions. How can I create a user defined function in Snowflake? So everything in detail at a data masking level. Okay, once it is done, I can go for a important one is NoSQL as a CLI. This is one more user interface. Okay, it is a command line interface. The command line interface will be having, like, you can open the command line interface and then you can type as, so here we have a SnowSQL. If you are installing in SnowSQL, then this will be executed like this. All the options will be available to connect. Okay, now this is the path. These are all helping words we have to be get as options. If you want to connect, you can use the hyphen a. If you want a username, then you can use this one. So using this SnowSQL, you can connect your SnowSQL. For example, I want to connect a SnowSQL with the help of this one, and I just want to see, I just want to look at you and how to connect a SnowSQL. So let us consider I am having this one. This is my account name. So this is the URL which is while you signed up process, this will be provided you, and I just use this as account name, and hyphen u is nothing but username. Yes, April 25. This is my username. So I'm trying to connect with account and username. It is asking a password. Now I provide a password like this. Now everything is done. Then it is connected. See, now it is connected as Snowflake. So now this is the version of a NoSQL. Now I am connecting. Either you can, okay, either you can write the code. See, this is the same like this. So once I open the session, so whatever the session it is empty white color. In the same way, this is the sheet for us as a CLI. You can write customer. You can create a customer table like this. For example, I want to create this one. I just want to create this one, and this is the one I want to create. I just copied from here. I just want to open the CLI, and before that I have to select the warehouse and database. Use my DB. This is my database, and then schema. Use schema and my schema, and then I insert. I'm going to write a code called as create table customer cus, and this is the name. And if I execute this, the customer is created. Now you can write a select a star from cus, and then you will get the information. That is, you created ID, name, age, and address. You are not inserted any value. You define the table. So either you can insert here itself, or either you can write the code here itself. Whatever you write, it is being connected with the Snowflake account, and this is called as command line interface, and this is called as Snow site. Okay, it is a web user interface. So this will be discussed in detail about a Snowflake SnowSQL. Okay, once it is done, I just go with the, so yes, once it is done, I we go with Snowflake with the Python. So how can I do the Python? Using Python, what are the data frame, and how can I load the data using Python worksheets, and everything will detail we discuss as Python level. Okay, and Python AWS we will cover all the Python related info and AWS related info, like two services we required for the Snowflake, and along with this all, okay, where everything will be discussed as in as a roadmap. So this is your TOC. Whatever I mentioned here, everything will be covered. Okay, along with that, I will give some add-ons like Snowflake AI. Okay, some importance of AI. So what is AIML? And I just go to the document AI, how to create a prompting and some features models. So I just give the some detailed information about this information to understand. Those are having data science students. If you are not having, then just listen what is the models and what is the document AI which is introduced in Snowflake to create a prompting. It is very easy to understand. It is like a LLM. It is LLM in Snowflake. Okay, so everything in detail, and the final we discuss this one features and everything as AI based. So what are Cortex AI? What is Cortex AI? What is document AI? What is model? So everything, how to build this document AI? What is the purpose of this? How to create a prompts? How to train a prompt? How to train a model? So everything is related to AI with Snowflake. Okay, this is our roadmap to discuss. Any doubts up to this, please let me know. And this is for demo you have, and then later we'll go one by one. And from tomorrow onwards, like whatever the session will be started, those are coming for these sessions. I started with all the detailing as a real time. So I have all the data, so related questions and every question and answers. So everything is ready for you, and you can practice on it. And I have this one, and see, this is the one. So all the data will be shared to you, and you can work on it. Okay, I will be share all the coding, and you will be get on practice as a hands-on. It is already being created by us, and the students will be done this, and you are also going to do the same. And also I have some MCQs to verify your knowledge. So I will some days, that is after 10 days, I'll share some uh, MCQs to verify yourself whether it is correct or not, and like that, like tests as an MCQs. And also practice questions I will be share. What are the interview, real time interview practice questions, because my students are, so many students are there as a practiced on these questions, and they will be facing the interview questions as real time. So the experienced and as well as freshers both will be covered in. Okay, I will share all the documents to you to prepare. Yes, you will be the best in Snowflake once you done this Snowflake course. I'm sure about it. And anything doubt, any doubts, please raise your questions. No questions?
Yeah. Hi, I'm Vishnuvardhan.
Yes, Vishnu.
So I would like to know what are the prerequisites for this course, like SQL, Python. I mean, how far we should know them?
So mainly it is SQL.
Mainly, it
If
will
you,
be
if you
SQL
have basic SQL is required, that's it. Not more than this. Basic SQL.
and data warehouse concepts as well, or any
No,
ETL
not
concepts.
required. Not required. I'll explain everything. That is what is ETL, and what is a Snowflake schema, what is star schema. So everything is data related, like data warehouse related, task and streams. These two are belongs to data warehouse. So everything I'll explain data warehouse concepts. No need of knowledge on it. So you just have a knowledge on basic SQL. That's it. How to insert, how to create, how to join unions. So like this,
Okay.
subqueries.
Okay. Mhm.
That is more than enough. And Python, if you had, then that more than that is it well and good.
Yeah, so I want to ask one more thing. I'm working in AW, I mean, in ETL now, like using AWS. So as part of this, are we going to create any glue job or something to integrate data from S3 to Snowflake?
No, no, we have a separate authenticators called as the external ID, or otherwise access key and secret key. With the help of these two authentications, we can ingest the data into Snowflake. We don't need a glue.
Okay.
Hmm.
So yeah.
We have a new
One more
concept
thing.
called
So
as external ID. Hmm.
okay. So what is the duration of this course?
This is for 30 hours. So the complete will be 30 hours.
Okay, fine. Yeah. Thanks.
Yes. Yeah. Any doubts? If you need any doubts on my profile, please go through the LinkedIn profile Ashwant Singh Rajput as a Snowflake developer. You will get all my testimonials. So I'm the expert in Snowflake and I'm delivering 450 plus as an online and offline as a trainer. So you can get just to go through my profile and you will find my expertise. Okay. And any doubts? I'm completely in Snowflake. So if you have a knowledge or not having knowledge on SQL, any prerequisite is not required. Only the SQL knowledge is only needed. So even if you are not having the SQL knowledge also, I can give some bit of knowledge to understand what is SQL and how to executing the query using the join operations and unions, the logics behind this. Okay, that is enough to, and later on you will be learn along with the Snowflake. Anyways, we are writing the SQL codes only, syntaxes only in Snowflake. So you will learn along parallelly with the Snowflake. The Python is an optional, but if you had, then well and good. So if you had, then well and good. If you don't had, then I will show you. That is how it is. And AWS is also not needed. I will explain and I will share all the content. What are the services? We needed two services out of the services whatever AWS provided. So we don't need any provided like a glue and anything. So these are external stages. So the Snowflake is suggesting us as S3 and IAM to integrate with the Snowflake. Okay. Okay, that's all for today's session. And if you have any doubt, please raise your voice, and otherwise I'll wind up this. Okay then. Thank you all.
Thanks for the session.
Yeah, thank you.